Welcome back. In this video, we're going to explore the topic of inheritance in Java. Inheritance is a very important object-oriented concept that comes into play when we begin to declare classes that share attributes and functionality but are not exactly the same. Rather than starting with a high-level description, I think this is going to go best if we really jump right into a problem. So, to get us started, I've created a really basic Java program. In this program, we declare two Java classes, the book class and the poem class. Books and poems all store a number of attributes. For example, our book can have a title, an author, a publisher, and a genre. It takes all these attributes as constructor input and provides a single public method, the print method, that we can use in our main program to print out information about any books we create. The poem does something very similar. It has a couple attributes, a print method, and we set its attributes through its constructor. I whipped up a really quick main function to utilize the book and poem classes. This function creates a new book and poem and then prints them out like we see here. This program works just fine, but it's much more complicated than it needs to be. If we take a look at our book and poem classes side by side and just look at their member variables, we're going to immediately see that both book and poem share two member variables, title and author. And the actions they take with these member variables, namely printing them out to the screen, are performed and achieved in very similar manners. This is a good sign that book and poem should be inheriting from one common class. This becomes extra easy for us to see when we think about books and poems as the physical objects that they represent. We can make the statement that books and poems are both forms of literature. Once we've come to this conclusion that books and poems share certain fundamental attributes, the attributes of all literature, we can start to break these classes down into component parts. Our book, for example, our book class, for example, has two real pieces. It has a title and an author, which are attributes we associate with all literature. And then it has a publisher and a genre, which may not be unique only to books, but which we don't necessarily consider all pieces of literature to have. So how can we exploit this knowledge? Well, we can build our book and poem classes so that they share on a fundamental level their nature as pieces of literature. But to make this happen, we're first going to have to teach our program what a piece of literature is. To do this, we'll create a brand new class, and we'll call it literature. And we'll assign to this class the attributes that the pieces of literature we've so far declared share. In our case, books and poems are already declared pieces, share titles and authors. And that makes some logical sense to us to make the statement that all pieces of literature will have both a title and an author. From here, we'll flesh out our literature class like we would any other. We'll give it a constructor, and in this case our constructor will take two variables, a title and an author, and assign them to the fields, much like we did with our poem and book classes. And while we're at it, let's give literature a similar print method to the one we assigned to books and poems. In fact, to save time, I'm just going to copy and paste the title and author lines from our book class. Now, if we wanted to, we could go to our main method and declare a object of the literature class. But that's not the point. That's not the reason that we've created this literature class. Rather, our goal is to make use of this literature class as a base from which to build on to declare more specific types of literature, like poems or books. To make use of our literature class, let's see how it applies to the existing poem class. Our literature class contains declarations and all of the functionality needed to manage a piece of literature's title and author. If we let Java know that there is an inheritance relationship between poems and literature, we should be able to remove all real references from title and author from this poem class. Let's first talk about this declaration of the poem class that we've modified. When we say that one class extends another, we're saying that there is a relationship between them, such that I can logically make the statement a poem is a literature. In more Java terms, we're saying that the subclass poem extends or inherits from the superclass literature. This means that when we create a poem object, it will have all of the members and functionality of the class which it extends. In our case, two of these members are title and author. The literature class declares these members and does a good job managing them throughout the class's functionality. So, we can remove these members from our poem class and we'll still be able to access them within poem's methods, because poem simply inherits their declaration from literature. We do need to make a slight modification to get this poem class working as intended, though. When we construct an object of a class that inherits from another, by default, the constructor of the subclass is going to begin by calling the constructor of the superclass. This confuses Java as we've had it set up right now because the poem constructor takes 3 variables as input, but the literature constructor is only expecting 2. To solve this, we should explicitly call the literature constructor within our poem constructor. When we're in a subclass, we can call the methods of our superclass using the super keyword. So in this case, we're going to begin our poem constructor by simply calling the super constructor or the literature constructor and passing it the attributes that we'd like it to know about. We can do something very similar in our print method. Because our literature class, our superclass, knows how to print out a title and author already, there's no reason for the poem class to implement this functionality. Here, we'll get the same behavior from our print method if we begin it by calling super.print instead of the original explicit printing lines. Now when the poem's print method runs, it will begin by calling the superclass's print method and then finally printing out the poem's style, which is not shared across all pieces of literature. While our poem constructor and literature constructor had different names and even took different styles of input, our two public void print methods shared between poem and literature are exactly the same. We'll talk about this a little more later, but for now we should know that we've made use of a technique called overriding right here. When we declare that a subclass has a method that's identical to one of its superclass methods, we've overridden the superclass method. When we do this, it's a good idea to use the Java override indicator. This is an indicator to future coders and some more arcane elements of our compiling suite that this particular method is hiding a method beneath it. When we actually run our code, Java gives preferences to the lowest or subclassed version of a method. So let's see if we've declared our poem and literature relationship successfully. Let's go back to the main method of our program and see if the poem portion of this program executes as it did before. When we run this program, we get the exact same output as we did previously, which is a great sign that we've set up our poem to inherit from literature in a logical manner. Now we can jump really quickly to our book class. And we're going to do, if I can stop making typing errors, the same thing very quickly. We're going to declare that book extends the literature class, and now we'll remove references from title and author in our book class, because now the literature class, the superclass, will take care of this. As with the poem class, we're going to need to explicitly call literature's constructor and pass title and author in. And then we can make use of our superclass's print method to simplify printing of our book. And once again, let's jump back to our main method and run it to make sure that we've done this successfully. There we go, the Lord of the Rings output just as we saw it before. Style-wise, this change is really great. By adding the literature class and then subclassing it to create books and poems, we've made our book and poem classes much more bite-sized and easier for a programmer to go through and figure out what's going on. But this change is not purely stylistic. By declaring this relationship between books, poems, and literature, where books and poems inherit from the literature class, we've given ourselves actual functionality that we didn't have before. Let's take a look at that in action. If we go back to our main method, let's pretend that rather than dealing with a single book and a single poem, we're dealing with a vast network and that we need to store them in some sort of data structure. With our original implementation, this would be a real challenge. There's not a easily accessible data structure that will happily store both books and poems. We'd probably have to use two data structures or break the strong typing that is the whole point of Java. However, with our new implementation, where books and poems both inherit from literature, we can store them in the same data structure. That's because inheritance is a relationship, meaning that we can, once we've inherited from something, make claims like a book is a literature and a poem is a literature. If that's true, then an array of literature objects should be able to store both books and poems within it. And the fact that we get no compile errors when we build this project is a really good sign that we're doing something legal. Now, for demonstration's sake, let's flesh out our array here. to contain a number of books and poems. And we'll modify our main method to print out directly from the array. Now, when we utilize our subclasses as though they were objects of their superclass, we do have to be aware that we're now referencing them as objects of that superclass. For example, when we go through and acquire an element from our literature array, even if that element is a book, we still can't attempt to access things like its genre field, even if that field was public. That's because the literature class, which we're now using this object as, does not have a genre member variable. But what we can do is call methods from our superclass that are overridden by the subclasses. So when we call the literature class's print method within our loop here, Java is going to prioritize the print methods of our subclasses. That means that when we run this program, we're still going to get the specially formatted output that we've attributed to books and poems, not the simplified version that we stored in our literature class. In fact, you may sometimes see methods that exist only to be overloaded by subclasses. These methods don't do anything, and we can tag them with the abstract keyword. Of course, if a class has methods declared abstract, it's probably a good sign that an instance of that class should never be explicitly created. If our literature's print method is abstract, we should never be declaring objects that are only a literature. We should only be using objects that are one of literature's subclasses. If we're going to go down this route, we should declare literature to be an abstract class as well. If we do this, of course, we'd have to get rid of the references to literature's super method. So I'm going to undo those changes for now. Let's take a look at a minor mistake we made when building this program initially. Initially, when creating our literature class, we declared that title and author were public member variables. As we hopefully know, we generally don't want to declare member variables public if we don't have a good reason to. It doesn't make a lot of sense for a piece of literature to change its author after it's already been declared. So really, author and title should be private member variables that are set in literature's constructor and then whose values should never change. Unfortunately, if we make this change to our literature class, we're going to limit our functionality in our poem and book classes. Let's say, for example, that we wanted to modify the print function of our poem class so that it didn't have to explicitly call the print function of the literature class. Like maybe we wanted to start it by telling us that we're declaring a poem here. Unfortunately, because we've made title and author private to the literature class, the poem class, even though it is a subclass of literature, cannot access these member variables in its explicit code. This is kind of annoying, and it seems like there should be some sort of protection setting in between private and public, where it's private for everyone except for subclasses of the class. And in fact, there is. This is the protected protection setting. And if we declare that member variables are protected, they're private, not accessible by anyone except the class and its subclasses. Just to reassure ourselves that everything we've been doing here is legitimate, let's run our program again and make sure the output looks good, which it does. After this, we should have a pretty good handle on inheritance. You can develop a lot of systems that really mimic their real-world counterparts, and you can write very elegant and functional code using inheritance and small classes that don't do a lot of complicated things in and of themselves. Thanks for watching.